Okay. So yeah, period is 2 pi. So from here to here is also 2 pi. You can see the little 2 pi down there. I'm going to have you graph not on the grids that good old Gina gives you. I make your graph like this. I'll actually show you a homework problem because that would be more helpful. Right? So there's first homework problem. Second, etc. Right? It's just easier to graph because the problem is when you get, sorry, scrolling like crazy here. When you get a period like this right here, right? Gina's little grid doesn't really match up and it gets weird to try to figure out where you're supposed to graph things. So we just make our own and then we just label it as we should, okay? All right, so period is 2 pi, amplitude, oops, I went too far, there we go. All right, so the period is a horizontal distance. Needed to graph one cycle of the function. The amplitude is the average distance between the max and min values. Okay. Give you a chance to write that down. So we've got sine and cosine with some A's and B's going on here. So A is the amplitude. The amplitude is always the absolute value of A. So put those absolute value bars around A. The period is 2 pi over B. Okay, so whatever's in this spot right here, we're going to put that in the denominator of this fraction. Sometimes this b right here is a fraction, right? So we do copy dot flip. And then I've got a little trick to help you figure out the intervals over which you will graph these things. So first question is, what's the amplitude right here? 1, good. I'm just going to write amp. What's the period? Right, so when we write period, we're going to write 2 pi over 4. Do you think you have to reduce? Oh, hell yeah, you got to reduce, right? Pi over 2. How do you reduce on your graphing calculator? Put the fraction in, and what do you hit? Math enter, enter is your friend, right? It goes from decimal to fraction. It'll also reduce fractions. Okay, what's the amplitude of this one? 7 over 2. The period is 2 pi over 1, which is still 2 pi, right? Because what's in front of the x is a 1, but you don't have to divide it by 1. Okay, what's the amplitude for number 3? 5, right? Because it's absolute value. Now the period here is a little trickier, but it's still not that bad. We get 2 pi. I'm just going to write it out like this. Like if I were doing homework, I'd never write that step, right? We do copy, dot instead of divide, flip. So what is the period? 6 pi, right? Just 2 times 3. Multiply fractions straight across top and bottom. So 2 times 3 is 6. Okay, and then when we graph these things, I have one more step for the period portion of the program, which will make it much easier for you guys. But we'll get there once we start graphing. What's amplitude here? 2. Period. 2 pi. I'm going to do copy dot flip right away, right? So dot instead of divide, and I'm going to make it 3 over 4. So we get 6 pi over 4. What's that reduced to? 3 pi over 2. Right? You can divide top and bottom by 2. Okay? So that's like as easy as it can get from a question standpoint. Did I leave my coffee somewhere? It's another. Oh well. Okay. What's amplitude on number 5? So, right, I'm taking this graph and instead I'm getting graph paper. Who wants graph paper? I'll hand out some graph paper. Anyone else over here? There you go. Yep. You good? You good? You get a graph paper smart? I would always take notes on graph paper. Makes it so much easier. Anyone else want graph? You want it? There you go. There you go. Anyone else? Graph paper? Okay. There's more up here. You can just grab it. It's 3-hole punch as well. Okay. So the amplitude is what? 2. Period is 2 pi. So here's what we're going to do to figure out these 4 tick marks. Right? So I have 4 tick marks, which common sense would say, why not just divide this by 4? What do I get when I do that? Pi over 2. And then I'm just going to count out. I'm going to write them out. Pi over 2, 1 pi over 2. 2 pi over 2 is pi. Then 3 pi over 2. And then 4 pi over 2 would be 2 pi. So this is a normal one. And then we can just write this graph. Pi over 2, pi, 3 pi over 2, and 2 pi. So those, right, pi over 2 is straight up on the y-axis. Pi is straight to the left on the x. 3 pi over 2 is the bottom. And 2 pi is the right side, okay, of the unit circle. So all you have to do, and I'm giving more space with 2, just because the graph looks better, right? Otherwise it gets all scrunched up in here and it's kind of a nightmare, okay? So, I didn't say what a sine curve, yeah. So sine curve looks like this. Let's talk about this pattern real quick. So we have a pattern with sine curve. Who had VK or Varus last year? VK or Varus. Okay, so they made you do 2 cycles of the sine and cosine. I just make you do 1, okay? Because if you do 1, you can do 2, right? So to me, it's a waste of time to do 2, but that's just me. So the pattern is we start in the middle for sine, right? This is sine. We go middle, high, middle, low, middle, right? So middle. This helps like 2 kids in the class. It's great. Middle, high, middle, low, middle. That's how that one goes. This one is high, middle, low, middle, high. Right? And that's without any like negatives or anything. Right? So this cosine one would go, right? And that's 1 period or 2 pi. The other thing I want you to notice is that if we, right here, let's do a different color. Right here is a cosine curve, right? So if I finish that like that, this cosine curve is just this thing shifted over 1 little tick mark. That's all it is, right? So sine and cosine are the same. It just depends where you start. So I don't know if you ever realized that before, but it's kind of helpful once you do. So when I start graphing this thing, I wrote out my little intervals here, right? So that's why I'm dividing whatever the period is. In this case, period was 2 pi right here, right? And I'm dividing that 2 pi into 4 equal parts. So that's why I'm dividing by 4. Okay? So when we graph sine, we start in the middle. Then we go high. Then we go middle. Then we go low. Then we go middle. And you draw your little sine curve. That was a pretty good one for me. My artistic talents are severely lacking. Okay, so not bad, right? But that's the easiest one. The only thing that gets weird is some of the intervals. And then we'll start doing transformations, not tomorrow, but Monday. And the transformations get tricky, right? Because we'll move this like left pi over 4, and it gets weird, right? But we'll figure it out. What's the amplitude of number 6? Amplitude's 5. So the period is 2 pi over 1/2, which equals 2 pi times what? So 2 pi times 2 is 4 pi, right? So our end of the graph here is 4 pi. So what's in between? If we divide by 4, then we have pi, 2 pi, 3 pi, 4 pi, right? It's easy when it's just going by pi's, right? Because you just count. Okay. Now we're doing cosine. Where do I start cosine? Middle or high?
High.
High, right? So we have 5 and -5. And we go middle, then we go low, then we go middle, then we go high. That was not as good as my sine curve, but close enough. Right? I don't care if it's wiggly like that. Like as long as you're hitting the dots largely and have the right shape of the sine or cosine, I'm good. Okay? Any questions so far? So these are all the easy ones so far. Okay? So, here we go. What's amplitude? 3 over 2. Period is 2 pi over 4. Right? B is 4 in this case. So our period is pi over 2. Now I want to divide that by 4, which is the same thing as multiplying by 1/4. Because it's easier if we just multiply by 1/4. And what do I get? You multiply straight across top and bottom, so I get pi over 8. So sometimes it's helpful because you get confused, right? Like I made some mistakes as I was doing this. You have pi over 8. Let's say you're not good at reducing fractions in your head. You can do 2 pi over 8, 3 pi over 8, and 4 pi over 8. And then you will always reduce the second and fourth one. Okay? So that reduces to pi over 4, which is why we got pi over 4 right here, right? And this one reduces to pi over 2, which is why we got the pi over 2 right there. Okay? So see if you can draw the graph. Probably in pencil would be a good idea. Pay attention to that negative. Right, so I'm just going to say 3/2 is 1.5 and just write 1.5 here. You could write 3/2 too, I don't care. Right? So we had to start down this time because there was a negative, right? Which means a reflection over the x-axis. I'll give you a minute. couple of people are still writing. I'm just giving them some time to get caught up. Right, so to me, this is helpful over here. Right, for some, especially if you're not good at reducing the fractions. You can just write that and reduce along the way. And then if it's already a fraction, multiplying by 1/4 instead of dividing by 4 right here, which turns out to be that anyways, right? It's just easier. Okay, we're good. We're going to do 9. So 2.5 is 5 divided by 2. So you could write 2.5 on your graph, negative 2.5 on your graph. The period, this one's a little more messed up. So I'm going to do copy dot flip right away. Right, so copied the 2 pi dot instead of divide, and I flipped 2/3 to 3/2. And then what do I get? I get 6 pi over 2. And 6 pi over 2 is just 3 pi. And then I just count by 3s when I'm listing them off, right? So I have 3 pi, 6 pi, 9 pi, and 12 pi. You get one in your homework that's 16ths as a denominator. You okay? That's how that look. You're like, wait a minute, what just happened? Right, so 3 pi, I add another 3 pi, 6 pi, add another 3 pi, 9 pi, add another 3 pi, 12 pi. Yeah. Oh, that's what I forgot to do, divide by 4. So, thank you. I saw the weird looks. I knew I did something wrong. You can always tell me, so it's okay. I'm not perfect. So let's divide them all by 4 right here, because that's easier. Then I can reduce. Because my period was 3 pi, right? And that's your clue. You ended up at 12 pi, so that means I screwed up. So that's a good built-in double check, right? Thank you for fixing my mistake. So 6 pi over 4 reduces to 3 pi over 2. 12 pi over 4 reduces to 3 pi. I try to get through the whole lesson without making a mistake, but you know, doesn't always happen. 3 pi over 4, 3 pi over 2, 9 pi over 4, and 3 pi. So negative cosine, where do we start? Up or down? Down. So we start down with negative cosine, middle, high, middle, low. Right, so draw your little cosine curve. And get the little loops on the end, right? It's not a parabola, it's a wave. It goes like that. Sound is in waves like this. So if you have that annoying question, when are we ever going to use this? In this class. You take calculus, again, if you're any sort of sound person, understanding how sound waves work is helpful. But, you know, are you really going to use that? Probably not. Okay? That is it. Homework time. 1 through 8 all. Bust a move. I've got answers up here if you want to checky. Right? You can make sure you're doing it right. Okay?